Good afternoon, everyone. Continuing our discussion on set theory. In the earlier class, we discussed the basics of set theory, that is finite, infinite, and then we discussed the set builder form and the roster form of writing a set. Then we also discussed a set can have the number of elements in finite way or infinite way. Now each element is to be written only once. Today we are planning to discuss about subset of a set. Now when you say subset, like your school has class 1, 2, 3, 4 up to class 12 say. Yours is class 11 say A section. So your class is a subset of your classes in school, right? If I say the set of natural numbers 1, 2, 3, 4 and so on, and then set of whole numbers 0, 1, 2, 3, 4 and so on. All natural numbers are whole numbers. So set of natural numbers is a subset of whole numbers. If a set contains all elements of the other set, suppose I have a set A as say 1, 2, 3 up to 10. Now set B, suppose I have 3, 6 and 9. B is a subset of A because B contains all elements of A. And then we write it as B is a subset of A. This is the symbol to show a subset. If I have another set C, which is say 8, 10 and 15. Now C has 8 and 10 which is in A. But 15 is not in A. Therefore, C is not a subset of A. When every element of a set is contained in some other set, then it is called as subset of that set. That is, B is a subset of A, but C is not a subset of A because 15 does not belong to A. That is about a subset. Now, if I have these sets which I have listed, this set does not contain any element, and we have discussed that it is a set which we denote as phi, which is a null set. If you write this, then it is not a null set. This contains phi, right? A null set is to be written either like this or like this. So this set B is having only one element and we call it as singleton set. So subsets of B, I am coming to subset of this also. Subsets of B are this and empty set. Understand, every set is a subset of itself because it will contain all the elements. And a null set, empty set is a subset of every set. That is, this set has two subsets. Number of subsets is 2 here and number of elements in B is 1. How many elements B has? Only 1. I am coming to this after I discuss that. Now if I have to list subsets of C. Yes, now C contains 2 elements. So first subset would be X, only one element. Second could be Y, then X, Y, all possible subsets, and then phi. Yes, now all these are subsets of C. Number of subsets of C are 4 and number of elements in C is 2. Right? Coming to D, again if I list all the subsets, First would be x, then y, then z. You have to do all combinations, all the elements. Then you have xy as one subset, then yz as another subset, then xz as the next subset, then xyz. Yes, and you all know phi, empty set is a subset of every set. That is 1, 2, 3, 4, 5, 6, 7 and 8. Number of subsets is 8 in this case, and number of elements in D is 3. Clear? Coming to this, if I list all the subsets, first is x, then it is y, then z, see the way to write, then it is t, yes, then two elements, xy, then xz, then xt, fine, then I take yz, then yt. I will not take yx because yx is same as xy. So yz, yt. Now I take zt. Yes, 2 elements. Now 3 elements. So x, y, z. Go systematically so that you don't go wrong. Y, z, t. Then x, y, t. Yes. Then x, z, t. Right? x, y, t, x, z, t. Y, z, t. Now I have all the 4 x, y, z, t and then 5. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That is number of subsets in this case is 16 and number of elements in E is 4. A null set. Now I am coming here. No elements. Number of elements in A is 0. Right? We know every set is a subset of itself. So this set will be a subset of itself. That is, subsets of A are only this phi null set. That is, number of subsets is 1. Yes, number of subsets is 1. Now, I want you all to observe one thing. When a set has 0 elements, it has one subset. When a set has 1 element, it has 2 subsets. Observe the pattern. When the set has 2 elements, it has 4 subsets. When the set has 3 elements, it has 8 subsets. When the set has 4 elements, it has 16 subsets. That is, if you see the number of subsets, they are 1, 2, 4, 8. It is going exponentially, power of 2 and 16. That is 2 to the power 4 is 16. Yes, this is 2 to the power 3. This is 2 to the power 2. This is 2 to the power 1 and this is 2 to the power 0. That is, if a set A has, say, m elements, then number of subsets of A would be 2 to the power m. If a set has m elements, then it will have 2 to the power m subsets. So 1 element, so 2 to the power 1. 2 elements, so 2 to the power 2. 3 elements, so 2 to the power 3. 4 elements, so 2 to the power 4. And 0 elements, so 2 to the power 0, like this. Suppose you have a set with, say, 20 elements, so it will have 2 to the power 20 subsets. Now, that is about number of subsets. This collection of all the subsets is called as power set. So this is a power set. For C, collection of all the subsets of a set is a power set. This is a power set. This also is a power set for D. Power set is a set, so it must be written in bracket. Yes, this is a power set for E. Yes, a power set is a set which contains all subsets of a set. So today's class we discussed what is a subset, number of subsets and what is a power set. Thank you.